Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. This example is one of the best question of type 2 error in a two-tailed test of continuous distribution. This question is from June 12, paper 72, question 7. An important advice: be kind and be humble. The weights x kilograms of bags of carrots are normally distributed. So population is normal. The mean of x is mu. An inspector wishes to test whether mu is 2.0. This means whether mu is 2.0 or not. This means this is a two-tailed test. He weighs a random sample of 200 bags and his results are summarized as follows. These two results are for sample mean and sigma cap square. Carry out the test at 10% significance level. See, H0 is mu 2.0. This means mu has not changed. And H1 is mu is not equal to 2.0. That means mu has changed. And this not equal sign means a two-tailed test. Therefore, this 10% is divided into equal parts. 5% here, 5% here. And the corresponding 5% value of Z is 1.645 here and minus 1.645 here. Now, X bar is sigma x upon n, which is 2.15, and sigma cap square. You know the formula of sigma cap square, and write all the digits of the answer. Now, let's perform the test. So Z test is x bar minus mu naught under root sigma cap square over ns. X bar is 2.15, mu naught is 2.0, and sigma cap square is, just copy this, divided by 200. Now this number is 1.565. Let's compare this number with the critical value. The critical value is 1.645 on upper side and lower side 1.645. Since our answer is positive, so we need to compare this value with this value. See, 1.645, our test value, is not in critical region. It's maybe here, before the critical region. So you need to mention this here, since 1.565 is less than 1.645, that is 1.565 is not NCR. Therefore, accept H0. And when you are accepting H0, that means you are accepting this fact. I mean, you are saying that evidence that mu has not changed. That is sufficient evidence that mu has not changed. This is the conclusion, because you accepted H0. Now, the next part of this question, which is very important, type 2 error. You may now assume that the population variance is 1.85. The inspector weighs another random sample of 200 bags and carries out the same test at 10% level. State the meaning of a type 2 error in this context. Very simple. Now, let's learn how to explain type 2 error in words in the context of the question. First, understanding meaning of type 2 error. A type 2 error occurs when a false H0 is accepted. we accept it H0. So a type 2 error can be made. So just mention this thing here. Concluding that mu has not changed. You accepted this. Accept H0 means evidence that mu has not changed. So mention this here. Concluding, just copy this line. Concluding that mu has not changed. This is the conclusion of this part. Just copy this here. Concluding that mu has not changed. But since this is an error, so mention this when it has changed. So this is the way to describe type 2 error in the context of the question. Just copy this thing, or very simple, copy this thing. This is one of the easiest way. Just say concluding that mu has not changed. Whenever you have to explain type 2 error in words, just copy this. Concluding that mu has not changed when it has. And extra work. What if the question was explain type 1 error? So you have to mention this. Concluding that mu has changed. This is for type 1. This is an extra work. When it has not. This is the best way to explain type 1 and type 2 in the context. For type 2, write this. Concluding that mu has not changed when it has. And here for type 1, concluding that mu has changed when it has not changed. Now the next part. Given that mu is 2.12, this is the new mean. Show that the probability of type 2 error is this. Now this is very important. For type 2 error, we must have a critical region. Now let's learn this concept very carefully. Stay focused. One of the most important part. And the question number is 2 part B. This was 2 part A. 2 part B. Probability of type 2 error. This is the probability of accepted region. For that, we must have critical region, because accepted region is the complement of critical region. Now let's learn how to find critical regions in two-tailed test. C1, C2. This sketch is for X bar and this is for Z. This is 1.645 minus 1.645. 5% area. Now we need C1. For C1, write Z test is equal to Z critical and Z test is C1 minus mu naught. Make sure you write value of H naught here. Sigma cap square over NS under root minus 1.645. So C1 minus 2.0 H naught, sigma cap square is 1.85 upon 200, minus 1.645. From this equation you can get C1. Now for C2, copy the same thing. Just write C2 here and positive 1.645. This C2 is here and this 1.645 is here. Just copy this. Just change this sign, and this is C2. Okay, let's check the values of C1 and C2. So C1 is 1.8418. First copy this. And C2 is 2.1582. So these are the two critical regions. So this is 2.1582 on X bar, and this is 1.8418. Now this is the probability of type 2 error between these two numbers. So type 2 is X bar 1.8418, 2.1582. But you have to use new mu, and new mu is 2.12. Make sure you use new mu while calculating the probability of type 2 error. It's 2.12. So while converting X bar into Z, we have 1.8418 minus 2.12. I think variance was 1.85 over 200. This should be 2.1582 over 1.85 200. You all know how to calculate this. You have done this in normal distribution. For formality, I'm writing the answers. This is, let me copy this. So this is minus 2.893 and 0.397. Positive number becomes 5.397 and negative is always 1 minus 5. Now use normal distribution table and get the values of these two. And the answer is 0.652. This is what we had to show, up to 3 significant figures. So this is the best question, one of the best question of type 2 error in a two-tailed test of continuous distributions. Hope this lecture will help you to understand this concept well. Good luck and Allah Hafiz.